Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome back, chemistry fanatics. Welcome to Chemistry Connections. My name is Andrew Neal, along with Isabella, and we're both going to be your hosts for episode 4, called Chemistry Behind Crime. And today we'll be discussing about forensic science and the chemistry behind it.
So what exactly is forensic science? It's tests or techniques used to connect the detection of crime with sciences, and it kind of helps you solve crime. Crime's not limited to, but including homicide, theft, kidnapping, anywhere that there could be some sort of DNA left at the crime scene that needs to be tested. It's mainly used by the U.S. government and justice system to help find evidence, and techniques could be fingerprinting, blood tests, DNA tests, finding wounds and bullet entries into bodies and walls.
Now, there's a lot of specific topics about forensic science, and all those correlate to chemistry as a whole. But as of now, we're going to start off with the chemistry behind blood. You want to continue talking about that, Isabella?
Yeah, so there's a lot of different aspects of what blood testing in forensic does. One of the main things is that you can identify the difference between animal and human blood, but that's not the only thing. Once you find out if something is said to be human blood, you can test it to find if it belongs to the victim or the unsub. You can also look at the way that the blood has fallen, and all of this has to do with the chemistry behind the different elements of blood and how it's all combined together.
Mm-hmm.
So blood is actually made of water, plasma, and protein, and we're going to talk later about the different bonds and why they're important.
Yeah, and so one of the most common ways as to identify what is actually blood and what just might be a unique substance or something other than blood is called the Kastle-Myers blood test. So the Kastle-Myers blood test uses hydrogen peroxide and phenolphthalein, and the sample as well. And during the test, the sample and the small amount of distilled water, hydrogen peroxide, and the phenolphthalein is mixed inside a test tube. Now, if the sample is blood, then the solution will turn into a bright pink color. However, if the sample is not blood, then the solution will remain clear. And now this correlates to chemistry because of the chemical reactions and redox reactions that confirms the sample is blood. If the sample is blood, then a component of blood called hemoglobin, which is the protein in the blood responsible for transporting blood, reacts with the hydrogen peroxide. This leads to the formation of an iron oxo species and hydroxyl radical. Both of these products can cause a redox reaction with the phenolphthalein, where either the iron oxo species and hydroxyl radical are reduced, and the phenolphthalein is oxidized. Since phenolphthalein creates a bright pink color, it turns the entire solution into bright pink.
So another important aspect of blood at the crime scene is the reconstruction and kind of the analyzation of how blood can spatter from a crime. For example, there can be just simple droplets left from a high angle vertically, or if somebody was lying down when they were hit, the blood would spatter out the opposite way of the entry. And all of these different spatters have to do with the way that the blood is bonded and how thick and strong the bonds in the blood are. So that can also be related to chemistry.
Yeah, there's many different intermolecular forces in blood. Some of them includes amino acid proteins with bond with each other. Due to the large sizes of amino acids, the London dispersion forces created between them are pretty strong. Then when the antibodies of blood find the specific antigen to bond with, they're able to create a really strong attraction. And although the intermolecular forces aren't that strong compared to intramolecular forces, the bond created between the antibodies and antigen is strong because so many are formed. This includes hydrogen bonding, electrostatic force, London dispersion forces, and hydrophobic links. Now, all these different bonds or all these different intermolecular forces in blood results in a thicker texture, which correlates to how when the blood falls and the impact occurs, it creates very specific blood patterns that can be analyzed and reconstruct a crime scene.
So now we're just going to talk about why this is important and why the chemistry behind forensics is used. So obviously, it's a really big deal that crimes need to be solved and criminals need to be found, especially in the cases of murder when you're dealing with blood or just any assault where there's blood. But also, crime shows have been growing with lots of popularity, and it's also kind of fun to just know what you're seeing on TV, whether it's real or not, because there's a lot of cases in crime shows where this process isn't done correctly and it's not accurate. Mm-hmm. So most viewers don't really know enough about forensics or the chemistry behind it to really tell if what they're seeing is real. But in reality, this is definitely a really cool subject, and it's important that people understand how all of this works.
Thank you so much, guys, for listening to the episode in Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.